Hi girls, this is a video with some examples of related rates. First of all, let's go over some theory. We can use the chain rule to solve related rates problems. For example, dy dt equals dy dx times dx dt. And in related rates, we're always looking for t because we're talking about rates. So this example's from the workbook, and there's a slight error in the workbook, so have a look closely at this example. Dx dt equals 5. Let's differentiate the expression for y. So dy dt, first of all, the chain rule, dy dx times dx dt. So dy dx we can work out by differentiating 4x minus 3. Dx dt we were given in the question, which is 5. Now we know that x equals negative 2 from the question. So we can substitute that in. 4 times negative 2 minus 3 all times 5, which gives us an answer of negative 55. So this question is about a ladder resting up against a vertical wall with its feet on horizontal ground. So let's draw a picture. Always in these questions, if you can, draw a picture. So the feet on the ground slip, and the instant when they're 3 meters from the wall, they're moving at 10 meters per second, and we want to know the speed at the other end of the ladder. So dx dt tells us the speed of the feet, which is 10. Dy dt is what we want. We know the ladder's 5. We know the horizontal distance is 3. We're going to call that x. We're going to call the vertical distance y. And we can establish an equation, x squared plus y squared equals 25. Let's differentiate that using our implicit differentiation. Solving for dy dx. Why do we want that? Because we need dy dx for the chain rule. Okay, so we have dy dx equals negative x divided by y. Now we need to know what x is. X is 3. We need to know what y is. Y is 4. Why? Because of Pythagoras. Pythagoras is 3 squared plus 4 squared gives us 5 squared. So dy dt, which is what we want from the question, is dx dt times dy dx. So that's 10 times minus x over y, substituting in the values we've got. 10 times negative 3 over 4, which gives negative 30 over 4, negative 7.5 meters per second, which means the top of the ladder is sliding down the wall at 7.5 meters per second. This one's slightly different because of different variables are used. We've got a metal ball heated so that its radius is expanding. At what rate will its volume be increasing? So we need the volume equation, V equals 4/3 pi r cubed. Let's differentiate that. dV dr equals 3 times 4/3 pi r squared, which is 4 pi r squared. Now we want the volume increasing, so we want dV dt. Using the chain rule, dV dr times dr dt. We have dV dr with an equation, and we have dr dt because that was in the question. So 4 pi r squared times dr dt Now the radius is 3 from the question, and r is 0.04 dr dt, and our answer is 4.52 millimetres cubed per second. Now I've included this one in your workbooks because it's quite a tricky one, and I want you to see one with an angle and one which is a little bit harder than the others. So we've got two cyclists leaving at an angle of 120 degrees. We want the distance between them, so we want Z. And you can see that we've got a triangle, but it's a non-right angle triangle. So we want dx to t. No, we've got dx to t, it's 12. We've got dy to t, it's 16. We want dz to t. Okay, so equation using the cosine rule. Just simplify that down. xy. Okay, now because we want dz to t, we're going to differentiate with respect to t. So 2z dz to t, we're doing implicit differentiation here, differentiating everything with respect to t. And using the product rule here, so first times the derivative of the second plus the second times the derivative of the first. Okay, now we want 2 minutes, the changing at 2 minutes. So at 2 minutes, x distance is 1440, y is 1920, dx to t is still 12, dy to t is 16, and we'll need to continue over the page. Okay, substituting into our equation. So we get a value of z equals 480 square root 37. Now putting it into our second equation. (960 root 37 to z to t) equals 142,080. Dividing through, we end up with z to t equals 24.3 meters per second.